Okay. All right. Hey. Okay, you guys, attention. Back up here. All right. So now for this right here, we have asymptotic unbounded behavior. So for this, I'm going to go through and talk about basically what's happening at an asymptote here. Bounded, unbounded behavior. So what it means is, what is it going to end up doing? Is there restrictions? Is there a place in which that I cannot do anything? So if we're looking at this function right here, the limit as x approaches -6 from the left-hand side, goes up to positive infinity. The limit as x approaches -6 from the right-hand side is going down to negative infinity. Conclude that the line x equals -6 is a vertical asymptote because both left and right-hand sides actually go to infinity. Now, would it be possible, I'm just asking you guys, let's say I have something like this, and my graph, yeah, I got another different color here for this. To be something like that and still be considered an asymptote. Say yes.
Yes.
Okay, that one. So it doesn't have to be different signs. It could be both going up to positive infinity and still be considered, okay, an asymptote, because at, in this case it was -6. At -6, this is going up to positive infinity from the left-hand side. At -6, from the right-hand side, it also goes up to positive infinity. So both those work, right? Okay, so yeah, so that we're figuring out where this is going to end up becoming the vertical asymptotes. Okay, so right here we have another one at 1. Okay, 1 from the left-hand side goes down to negative infinity. 1 from the right-hand side goes up to positive infinity. Conclude that the line x equals 1 is a vertical asymptote. So here is the function that we have right here. Okay, now, last time we talked about some removable discontinuities, right? Yes, say yes.
Yes.
Okay, good. So we're going to factor this out a little bit just to see if I can have a removable discontinuity here. So let's take a look. So can I change this up? Can I change up the numerator? Say yes. Yes. I'm going to take out that negative. So if I take out that negative, it's going to be a negative. What's left over? Very good. X minus 3. I'm looking for the x minus 3 over. Now, can I factor the denominator? Remember, this is a negative, so if this is a negative, that means my two factors have different signs. When I multiply together, they have to have different signs. This plus right here says that the bigger one is positive. Since I have two different numbers, they have two different sides, or two different signs, and the bigger one is positive, right? So now, what two numbers are going to multiply to be -6, but add together to be +5? 6 and 1, right? So which one's going to be positive? 6. So it's going to be a x, right, plus 6, and a x minus 1. So by factoring that out, I can actually look to see, is there any removable discontinuities? No, there's not any removable discontinuities. And a removable discontinuity would give me a what? A hole, right? So I know people that are here on their day off are not just going to like text and not pay attention. It's all right. It's all right. We cool. All right, so right here, so it's basically we're trying to find the vertical asymptotes for this. Now, horizontal asymptotes. I hate the way they wrote this. This sucks. All right, now let's go back to the next page. Let's see. So, now, these shortcuts for determining horizontal asymptotes. If the degree of the numerator, remember that's top of the fraction, is less than the degree of the denominator, right? There is a horizontal asymptote at y equals 0. Okay, so right here. So the degrees, the bottom has a greater degree, right? So that means that it's going to be an asymptote going to 0. Okay, so I think about this in terms of infinity as you're doing this. So the bottom is actually going to go to infinity faster, so therefore it's going to go to infinity but never touch infinity, right? Okay, so that's going to be an important part here. So we have that. So this is going to be the type of thing that's going to be going to infinity. Okay, and so it's going to be 0. Okay, both sides are going to be approaching that. So even you notice the little wonky thing in the middle, it's coming up to 0, but it's not going to be 0. So that's the degree of the numerator. So this is important. These keys right here are going to help you out with a lot of this. The degree of the numerator is equal to the degree of the denominator. Okay? The horizontal asymptote is the leading coefficient of the numerator, leading coefficient of the denominator. Just like I was saying with my degrees. Okay, so I have my degrees right here. Okay, like I said, I'm thinking about this in terms of going to infinity also, right? So I'm going to have an asymptote here. So if I look at this, I have an x squared over x squared, so I'm just going to cover up the rest of this, unless I have another x squared. But if it's written correctly, you're not going to have another x squared. So it's going to be the leading coefficients of the highest degrees. So I have a 2x squared over a 1x squared, right? So now it's just going to be the fraction 2 over 1, so that gives me 2. So in this case, I'm going to have right here 1, 2. I have a horizontal asymptote at 2. Questions? Questions? Are we okay still?
Yeah.
Okay, so now let's take a look at this next one. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Now, because that means that if I'm talking about going to infinity, that means that this is going to end up going up to infinity or going down to infinity, but there's only one exception to this rule. Only one exception. If the degree is only 1 degree more, like this, so this is 1 more than this, you would have to do long division to get your equation. In that sense, I will actually do the long division. So, yeah, it's going to be, so doing long division, so outside goes the bottom number, inside goes the top number. And as you're doing the long division, you have to make sure every single degree is counted for. If it's not counted there, if there's not a number, let's say there's not an x squared. If there's not an x squared, what would I put there instead? 0. You would have to account for every single one. That would be a 0x squared. Because otherwise your lining up doesn't actually work. So on the x side, I'm going to have, there, okay, 2x cubed plus 4x squared minus x minus 5. And on the inside goes the rest of this mess. X fourth minus 2x cubed plus 5x squared plus 3x plus 1. Okay, there we go. Now, this is actually going to be like a very, very short one. So, now, I want you guys to think about this mathematically. If this is 1 more than this, if this is 1 more than this, and I'm dividing it out, take away 3 of those degrees. Take away 3 of these. You're going to end up with just an x, right? You would have 1 degree left, right? So that would just give you a straight line of like y equals something x, right? So you're going to end up with some equation of a line that is just y equals 2x plus b or something like that. That's what you're going to end up having, because you're going to end up having a straight line, okay? If it was an x squared, that would be like a parabola, wouldn't it? Yeah, so I'm not going to have that. I'm going to have a slant asymptote. So it has to be a straight line. So that means it's going to be an equation of a line in the form of y equals mx plus b. Right, there we go. Plus b. That's a b. There. Now, for this, I know you guys haven't done long division in a while. I have to make this one into this. So to make this into this, what would I multiply this by to make it into this? I need one more x, right?
Yeah.
I need one more x. So I know I'm going to need an x, right? But now, how do I get rid of a 2? I have 1 here. How do I get rid of a 2? 1/2. I would have 1/2. So if I multiply this by 2, that's going to cancel out that 2, right? So I'm just going to be left with 1. So now, this is my first term. So I'm going to go through and distribute this all the way across. So this 1/2 times this is going to give me just x to the 4th. 1/2 times this is going to give me 2. So it's a positive 2x cubed. 1/2 times this is going to give me negative 1/2 x squared. And 1/2 times this is going to give me a negative. That's going to be 5/2 x. Yes? Now, we're doing a subtraction. So whenever we're doing this, we're going to take this away. So this next notation it's not common. This is one that I do all the time. So whenever I have to do it, because I have to think about it and I have to visualize it because I'm not really good at doing this. So I have to visualize it, so I have to show what I'm doing. This is a subtraction, so I'm going to put a parentheses around this piece right here. And I'm going to put a minus sign there. Because you're subtracting the whole thing, right? So if I'm subtracting all of it, that means I'm actually need to distribute a negative into there. And that's one of the things that's not taught very often in the Algebra 3-4 or the pre-calculus with this right here. You have to distribute a negative to make sure you're subtracting correctly. So if I'm going to make this right here, I have a positive here and a negative here, so that goes away, right?
Yeah.
So that piece right there becomes 0. Now if I distribute here, that's going to give me a positive, right? So it's a positive, and so that's a negative now. So I have a negative minus, so that's going to be a bigger negative, isn't it? So it's a negative 4x cubed. All right, before I go on to the next one, is everyone okay with what I'm doing here? Anyone have questions? Yes?
How did you get the 1/2?
How do I get the 1/2? Okay, so now, think of it like this. I need to cancel out 2, right? So if I'm looking at this, I know that I need to get this to equal this. So it's kind of like taking this and I have to equal 1, right? So I know it's going to be something times this equals 1. So it's like a times 2 has to equal 1. So mathematically, that's what it's going to look like. I have an equation because I have to always match that leading coefficient. Because my leading coefficient has to cancel out to 0. So by doing that, it's a, and that's eventually going to be my 1/2, right? So what would I do to get a by itself here? Just divide by 2, right? So divide by 2, so I get a is 1/2. So in my long division, I kind of did it in my head right here. So in my long division, I always know I have to make it look like that. So sometimes you're going to get some really crazy type of fractions out of this, but that's kind of how it goes. And you know, you're going to end up canceling out a lot of this as you go with this. All right, you're welcome. All right, so we're here. So now the next thing I have to cancel out is what? Say negative 4. Negative 4. To cancel out negative 4, it's basically here. I'll do it again. So in this case, it's going to be a times 2 equals negative 4. right? So I'm trying to figure out what number I have to multiply here. So it's going to be divided by 2. A is negative 2. So now it's going to be negative 2. Now, this is x cubed and this is also x cubed, isn't it? Does it need any more x's? No, it doesn't need any more x's. So that means that I'm going to end up be done after this point. Okay, so now from here, let's go ahead and actually figure out this. So given this, now I'm going to do my distribution again. So, oh crap, no, I didn't finish what I was doing. I'm sorry.
Yeah.
I got sidetracked. Okay, you guys in the video, back on YouTube, I'm sorry. Okay. Okay, so now we're doing this part right here. So I have a negative. Negative is going to make that a positive, right? So that's going to be a positive. So 5 plus 1/2. 5 plus 1/2. How many halves am I going to have? So off to the side, if I'm going to do fractions, right? Fractions are your friends. So it's 1/2 plus 5. That's 10 halves, right? So together, that's going to give me 11 halves. So if you always think about it in fractions, all whole numbers, you can make it in whatever fraction you need. Okay? So I have this one right here. So I get 11 halves. 11 over 2 x squared. And now this next one right here, so it's minus, minus, so that's going to make it a plus. So it's a plus, so now I have 5 halves plus, now that 3 is going to turn into what? 6 halves. Very good, 6 halves. So I get how many halves? 11 halves again. And that's x. And now I bring down my last term right here. So I bring this down, so it's going to be a plus 1. So I brought down that plus 1. So now I'm going to go through and do my distribution of my negative 2. Sorry, I was a little bit ahead on here. Yeah. So is everyone okay with what I've done so far? Anyone questions before I go on to the next part? Okay. Yeah, so now I'm distributing a negative 2. So this is going to give me a negative 4x cubed. Now I'm going to line that up here, so it has to go on this. So negative 4 x cubed. Now negative 2 times positive 4, that's going to give me a negative 8 x squared, right? Okay, so negative 8x squared, and this is going to be a positive 2x and plus 10. Again, with that step, I am subtracting. So now I'm going to go through, take a look at this right here, put parentheses around that, and since I'm subtracting, I have to notate that I'm subtracting that. Now, I'm distributing. So negative, negative gives me a positive, right? So a positive and a negative, so that gives me 0 again. So every single time I'm doing this, I'm trying to actually get rid of my first term every single time. And the rest is just going to be leftovers. Anyway, all right, so now negative, negative makes it a positive. So we have positive. It's going to be my 11 halves plus that 8. What is that 8 going to be? 16 halves. So it's going to give me, okay, very good. So 27 over 2 x squared. Now, again, I have negative and this positive. So negative and the positive. So that means it's going to be a negative. So I'm going to have a positive 11 halves. Okay, so, all right, we're back to here. So I have my 11 halves, right? My 11 halves, and since this makes it a minus, then it's going to be a minus. What's that going to become? 4 halves. Which is going to give me, how many? You say 9?
Sorry,
7. 11 minus 4 is 7. So which one's bigger? Yeah, it's positive, right? Okay, good. Alright, so it's going to be a positive 7 halves x. I have a positive and a negative, so that makes it a negative. So that's going to give me a negative 9, right? So, since I don't have any more here, this is my leftovers. Okay? I know my equation is going to be right here. So, by dividing it out, I'm going to have this as my remainder.
We can go to the negative powers.
Huh?
We can go to the negative powers.
No. No.
I don't know.
Alright, so it's going to be plus all this over this. 27 over x 2x squared plus 7 over 2x minus 9 all over 2x cubed plus 4x squared minus x minus 5. So yes, it is a lot of work, and it normally comes out to be a lot more basic because your equation of the line is going to be this. Usually it just comes out like all the rest will eventually cancel. But yes, long division, that's what we end up with.
Does it got different answer?
They do?
Yeah.
What?
I think it's right.
They didn't actually show the work on this, so that's why I'm right.
Because look on the bottom they've got minus 4x squared, not plus 4x squared as in the cover. They've got different
Oh.
sign.
That's weird.
I know.
Okay, so they did it wrong. Ha ha! Yes, I have proved you wrong. Thank you. Thank you. Good job. Yeah, they did the wrong side.
Wait,
Huh?
I did it too.
Look. They used the wrong side.
Or maybe you used.
No, I did not.
In the problem it says plus.
The problem says plus. They use the negative. Yeah, sign errors. Yes.
We just like the government.
In your face, book.
I'm so proud.
We did it right. Don't even play. Anyway. Alright, so what the hell am I doing? Typos. Bro, I'm a professional. I get paid to do this, and I make them all the time. You said professional cheerleader? Wow.
I'm not that good.
Okay, anyways. Alright, so let's take a look at this. We already talked about this. Okay, now time to talk about boundless. Okay. Alright, so let's take a look at this. Now, the topic of being bounded. Bounded. That means, okay, okay, let me ask the weirdo over there. Yes, you know who I'm talking about. Okay, so if you are bound, what does that mean? Yeah, okay, you're restricted, right? So that means can't go anywhere, or can't go certain place, right? Okay, so, yes, you. All right.
That's a big fact.
Now, this one right here, the end behavior, so going to negative infinity, the end behavior, it goes up to positive infinity, right? End behavior as it goes to positive infinity, it goes up to positive infinity, right?
Yeah.
So bounding means where can it or can it not go. So it's not bounded, so it is unbounded above, but it is bounded below. That means that there is a place in which that it cannot go. The function is stuck at the lowest point, which is right here, and I'm not going to try and count all those stupid things. Anyway, so it's bounded below, but not above. So it goes up to infinity, but it doesn't go down to negative infinity. Next one. This one's bounded above, but not below. So it can go down to negative infinity on both sides. Okay? And now right here, it is bounded above. So that means that it's restricted, can't go any further there. So it goes down that way. Now this one is bounded above and bounded below. Okay, this one right here, so it goes up, but if you notice the end behavior, this is going to, okay, this is going out to infinity. It looks like it's going to go, like an asymptote at 0, right? Okay, so we're going to go to there. This one, as it goes to negative infinity, is going to 0 from the other side, from the negative side, right? So it is bounded above and below because those things are going, looks like it's going to some horizontal asymptote here. Okay? Alright, so let's take a look. We're going to use some of that information that we figured out a couple minutes ago. Okay, determine equations that asymptote the following functions algebraically, confirm your answers graphically. Now, first thing, let's go through and factor this. I'm going to try and factor to see what we have. So I know that this thing, x squared minus 16, that's the difference of squares, isn't it? Say yes.
Yes.
Okay, so on the bottom, it's going to factor to be what? X minus 4, x plus 4. Okay? So, right here, what is this going to tell me? So, I know that I'm going to try and factor it. This number's a positive. So it means my two factors have to be the same, right? They have to be the same. This number right here, the factors are positive, right? Because they both, when I add them together, have to become a positive. So this says the signs are the same, and this says they're both positive. So given this much information, what are the factors of 12 that add together to be 7?
4 and 3. Negative 4, negative 3. Negative.
Positive 4, positive 3.
Yeah, like, I mean, the x's will be negative 4 and negative 3, and if we write it in that one, it will be x plus 4 and x plus 3.
Factors.
I know, I mean.
Plus 4, x
Yes.
plus 3.
But the x's are equal to the
I know, but we're looking for.
I'm just
I know what you're saying. Man, trying to kill my vibe here. Seriously. All right. So, what are restrictions here? Let's start with the restriction. What is the restriction on my domain?
4, negative 4.
This guy in the right spot?
Yeah.
Okay, good. All right. So negative 4 and 4, right?
Yep.
So I know that I could actually cancel out one of these, right?
Yeah.
So I know that if I can cancel out one of these, what does that make?
We can.
What does it make?
Asymptote.
I heard it a couple times. It's a hole. It's a hole. It is a removable discontinuity, so therefore it's a removable discontinuity is a hole. It's not an asymptote. It's a hole. So that's going to be a hole there. So if I'm looking at the graph is going to look continuous, but when I try to plug in at that point, it's going to say undefined, because that's going to be my hole. Now right here, I have this side right here. So this is where my x, my denominator, is going to be equal to 0, right? So because of that, this is going to give me where? It's going to give me an asymptote where x is equal to 4. So I should have an asymptote where x equals 4. I have a hole. I have a hole at negative 4. And let's take a look. They're the same degrees, aren't they? Okay, what'd they say about it if it's the same degree? Cover it up. Leading coefficient. So my horizontal asymptote, 1. So it's going to be y equals 1. Does that make sense? Okay, so now let's go ahead and take that calculator and confirm your answer graphically. It is Control plus. Control, divide, x squared plus 7x plus 12 over x squared minus 18. All right, so we're looking at our graph. I'll give you guys a second to actually put that in. Okay, is everyone ready? Hey, the guy, you. All right, looking at this, is this bounded above? No, it's not bounded above. Is it bounded below? So these calculators are very smart, so I'm going to check a couple things. So we said that there should be a hole where? At -4. So watch this. Menu, trace, just trace the graph. Okay, so I have trace on. So once you turn trace on, all you have to do is enter the number. So I want to know -4. It automatically comes up with the x equals -4. Hit enter, and it says undefined. So there's my hole. That's the hole. Now let's take a look at the other one. Well, you said +4, so hit +4, hit enter, also undefined. Okay, there's my asymptote. The limit as the asymptote approaches from the left goes to -infinity. The limit as the asymptote approaches 4 from the right goes up to +infinity. Is everyone okay here?
Yeah.
Did everyone actually get that far?
I got it.
Anyone struggling with the calculator? No? We good? Okay. So I'm going to go on to the next one then. All right, so if I'm doing the next one, let's see. All right, this next one here. This next one says 2x squared plus 3x minus 5 over x minus 3. All right, so I'm looking at this one here. So now let's take a look. Degrees. Start with my degrees. So to my degree, which one's bigger? The top's bigger. So the top's bigger. So that means that it goes up to something, right? Okay. So if you guys looked at the previous thing, it says the degree of the numerator is less than the degree of the denominator. Horizontal asymptote. Wait, hold on, where are we at? Degree of the numerator is greater than, no horizontal asymptote, right? So no horizontal asymptote. But if it's only 1 degree more, look for a slant asymptote, right? So long division. So this is going to be an easier long division. So on the outside, I'm going to put x minus 3. On the inside, 2x squared plus 3x minus 5. Right? Okay, so now for right here. So how am I going to match this one right here? So it's missing one x, right? So it's missing an x, so I multiply by 2x, right? Is everyone okay with my 2x? So I got 2x, and I'm going to use that. So that's going to give me a 2x squared minus 6x. Put my parentheses, subtraction. That's going to give me 0, and that's going to give me a plus 9x. Bring down, minus 5. So, how am I going to get this one right here? By 9, right? So it's going to be plus, it's positive, 9. So as I distribute that, it's going to give me 9, right? 9x minus 27. So now from right here, I distribute, that's going to be a 0x, right? And that's going to give me a positive 22. And so it's going to be plus 22 over x minus 3. So my equation of my slant asymptote here, my equation of my slant asymptote is going to be y equals, make sure I'm still on here, 2x plus 9 plus 22 over x minus 3. So I have an equation of a slanted asymptote right there. So let's go ahead and actually calculate that one. Let's put it in the calculator here. So I'm going to put this in the calculator. All right, what did we forget to do? What did we forget to do, you guys? I just noticed it right now when I was looking at the problem. So we did a slant asymptote, right? Hey, pay attention. We did a slant asymptote. Okay, we have the slant asymptote. Is there a horizontal asymptote? Say no. No horizontal, but was there a vertical asymptote? We didn't check for vertical asymptotes. Okay, can I factor that? There should be right here, right? So to figure out the vertical asymptotes, we have to factor this. So, I don't know what method you guys do, because every time I do this, it's like wonky for most people. So I do AC method. A times C equals some number, then A plus C has to equal the B. A and C, so it's going to give me negative 10. Okay, what two numbers of negative 10 is going to give me positive 3?
5 times negative 2.
So it's going to be a positive 5, right? 5 and minus 2, right? So those are my factors I'm going to replace my middle term with. So I'm going to replace this here. So it's going to be 2x squared plus 5x minus 2x minus 5. All right. I know I've seen some people actually do that weird wonky x thing. Okay, I've never learned that, and a couple people tried showing me. I don't know why, it just doesn't click in my brain. So I always do it this way. So factor the best way you guys can. So, yeah. Is there, hold on. Is everyone okay with factoring it? Does anyone have questions on the factors? Okay, so now, factor by grouping, so I'm going to group 2 at a time. I'm going to take out an x, and I'm left with x, 2x plus 5. I'm going to take a negative out, so a negative 1. I'm left with 2x plus 5. Now, they both have a 2x plus 5 in common. 2x plus 5. And the junk, what's left over? X minus 1. So there's the factors in the numerator. So now for this right here, I have a 2x plus 5, x minus 1 over a x minus 3. Why did I have to factor that? Just see if what? If there is a removable, right? If it's removable, that's going to leave you a whole. If it's not removable, that is my asymptote. If you cannot remove it, that's an asymptote. If you can remove it, that's a whole. Thank you. All right, so right here, so we're going to have an asymptote at x equals 3, right?
Yeah.
Okay, at x equals 3. So I have an asymptote. Here's my slant here. And I have a vertical at x equals 3. Okay, so let's go ahead and take a look at that now. So I'm actually going to graph my asymptotes also. So let's take a look. I'm going to say there we go. All right, so it's going to be, what was it, 2x plus 9 plus 22 over x minus 3? Is that correct?
Yes.
Okay, so now for this one, what? I did something wrong. Yep, I did something wrong again. All right. Doc. Huh?
It's over.
Well, yeah, because I mean, you just basically solved it, so it's the same equation.
We did this, but no, it's what's left over is what we're putting in.
Can't you just put 2x plus 9?
Make sure you want to start it.
I know, right? Not really, but I'll do it anyway. Because if I make a mistake, then it's fine. The slope's not right.
Sure.
Okay, I have this one here. No, it's not. The slope's not right on this. Yeah. Anyway, I'll come back to this one. I'll come back. While we're actually working on this, I'll figure out what the problem is there. Okay. All right. So now let's take a look at this. Bounding. So what was the bounding on that last problem? Is there an upward bound?
Yeah.
Okay, it's bounded above. Is it bounded below?
No.
No, because it went straight down, didn't it?
Yeah.
Okay, so let's take a look at number 3 then. Taking a look at number 3. Now, which one has the higher degree?
Bottom.
The bottom, right? So bottom has the bottom degree, has the greater degree. So what does that mean? Horizontal asymptote at, so I have y equals 0. What about vertical asymptotes? Is there any place where this is going to equal 0? Nope, there's not going to. Because this is a plus sign right here. So if I did the math on this and I say that x to the 4th plus 1 equals 0, x to the 4th equals negative 1, right? Is it possible to actually getting a an even power, x to the 4th getting a negative 1? No. That's where you get imaginaries from. So that means right here, if you were to take the 4th root of this, you're not going to get that number, right? So this one is not going to work out. So there is no vertical asymptote, but there is a horizontal asymptote right here at y equals 0. All right, so now let's graph this one right here. Is this bounded above or below?
I need you to fill out, there's a couple papers there. I need you to fill out, sign that one, and fill out one of the papers before you go, okay?
Okay, so let's go ahead and take a look at the graph. I'm going to clear my graph now. Okay, right here. So we had, what was it, x to the 4x cubed, 4x cubed over x to the 4th plus 1 when you actually enter this, make sure you don't actually put your x to the 4th plus 1 in the power. You have to like arrow over first before you can do that. So looks like this thing right here.
Okay, you sign that, and you have to fill out one of those other papers.
Okay, so now, is this one bounded above? Yes. Is it bounded below?
Yes.
Okay, good. All right, so I think we've actually covered all that. And let's go to there wasn't more practice, additional practice. Oh yes, right here. So, additional practice, you guys right now are going to, additional practice right here. You only 2 questions for this. So I'm going to let you guys solve these.